Acid-base homework number 1, definitions. I'm giving you a choice as to what to define for your homework. In the quiz, you will be told what to define. So here are some examples of what you could be asked on the quiz. You could be asked, what is the Bronsted-Lowry definition of acids and bases? Use an example or a chemical equation to help describe this definition. Well, remember that the Bronsted-Lowry definition of acids and bases involves the transferring of a hydrogen. So you should be able to pull out an example of an acid and a base that fit the Bronsted-Lowry definition. Also in that, you should have a discussion on conjugate acids and conjugate bases. They go with the Bronsted-Lowry definition. Or explain why the neutralization reaction of a strong acid and a weak base gives a weakly acidic solution. Use an example or a chemical equation to help describe, or the corollary, why the neutralization reaction of a strong base and a weak acid gives a weakly basic solution. So these two, the explain whys, these are pulled directly from the e-text. So you could view there for some guidance if you're still confused. Number 2, what's the pH of a solution with a hydroxide ion concentration of 4.5 times 10 to the negative 8? And it specifically says to record to the 10th place. So we're looking at 4.5 times 10 to the negative 8. So let's start there. So our hydroxide ion concentration is here. Now, in order to get the hydronium or the hydrogen ion concentration, we need to use the expression that Kw is equal to the hydrogen ion or hydronium times hydroxide. Now we have hydroxide and we know Kw. Kw is a constant. Kw is 1.0 times 10 to the negative 14. So we plug in what we know and we solve for what we don't. Make sure you're entering these numbers into your calculator correctly. So the hydronium or hydrogen ion concentration should be 2.2 times 10 to the negative 7. Now I actually have 2's repeating here. I leave that in my calculator and then I take the log of that value. So pH being the negative log of the hydronium ion or hydrogen ion concentration. I put this number in here, take that negative log, so I find a pH is 6.65, etc., etc. So because it specifically said the 10th place, and I'm not sure where you're going after this class, I will accept either 6.6 or 6.7. So I'm just going to put in my 6.6, because that's how people are being taught in most of the science disciplines anymore. And then calculate the hydronium ion concentration of a solution with a pH of 3.4. Now it's important when you're working these problems that you should be able to work these problems any which way they're given. If you're given a hydronium ion, a hydroxide ion, or the pH, you should be able to calculate any of those 3 variables. So we have a pH of 3.4. So we need to put that in our calculator as well. So the hydronium ion concentration, ooh boy. If we look at this from, well, how do I put this in my calculator? Your hydronium ion concentration is going to be, you have a button that is probably second log, and on my calculator I have 10 and then I have a little box that's filled in. So what I would do is I would punch second and then log, and that gives me this 10 with a little box, and then you type in the negative pH that you're given. So negative 3.4 is what I have. And so I get a hydronium ion concentration of 3.98 times 10 to the negative 4th. Report 3 sig figs in standard form. So 0.123398 is what I would report. So I believe that's 10 to the negative 4th. Number 3, for the following acid, we're going to write the ionization reaction with water, the Ka expression, including the value of the Ka, and we're told to show as much work as we can. Now, So the ionization reaction with water. So here we have formic acid, CH2O2. And it is okay if you want to come up here and copy this and paste it in. Now it might be helpful to you to write this way. And although we haven't changed the chemical formula, what we have changed is where that H goes. And that on the end, it's easier for me to see that that is a ionizable hydrogen. So I'm going to use my text editor and then an arrow. I'm not sure how to put an arrow in without the HTML editor, and I don't expect you to understand the HTML for this. So I'm just using a dash here, dashes, and then I'm using the greater than sign, also known as alligators, depending on where you learned your greater than and less than. So then I'm going to show that that is ionized, and I show that by making hydronium. And so I need to change this 3 to a 2. It has taken on a hydrogen ion. It's now aqueous. I need to put that into the superscript and my counter ion. So I'm going to take this part and give it a negative sign. So there is the ionization reaction with water. So the Ka expression is going to be the concentration of my products, and I'm just going to copy and paste these here. That'll make it a little bit faster. Concentration of my products, I'm going to leave the aqueous off, however, and the concentration of my reactants. Remember that water does not go in the Ka expression. So there's my Ka expression. So now determine the pH of a solution at equilibrium that starts with a concentration of 1.55 moles of acid. So I'm going to take this over to my work area. Now I need to set up the equilibrium. So if I make an ice table, and it's going to be kind of a squished ice table here, and initially I have 1.55 moles of my weak acid, and I have none of this. I'm going to change this by some value x. So my Ka expression is then going to be, each of these is going to be an x, and then this is 1.55 minus x. Now what I didn't do is look up what the Ka value was. So this is formic acid. I'm going to scroll down, and here we have the dissociation constants that it is found in the classroom as well. So here's formic acid, 1.8 times 10 to the negative fourth. So 1.8 times 10 to the negative fourth, and that's going to be equal to x squared over 1.55 minus x. Now because of this difference here, it's a reasonable assumption to simplify this. So 1.8 times 10 to the negative 4 is going to be equal to x squared over 1.55. Make sure you're using your calculator correctly. Multiply 1.55 by both sides. You get an x squared is equal to 2.79 times 10 to the negative fourth. Take the square root of that value, and I get an x is equal to 0.0167. I have a few more digits there, but that's what I have. Go back, double check what we're asked for. We're asked for the pH. So this is the hydronium ion concentration. In order to find the pH, I need to take the negative log of this concentration. Now I have more digits in my calculator, and I'm just going to leave them there. And so I get a pH value of 1.777. Come back over here. Does it give me? It does not give me a report to a value. So I'm going to go with 3 significant digits. There is some disagreement in the chemical world as to how many significant digits a pH should have. I'm going to go with 3 because that's safe for me. 1.78. If you end up giving me 4 sig figs, 1.777, I accept that as well. pH of 1.78 is safe, so I think I've answered all of my questions. Go back and double check. Write the ionization reaction with water. I did that. Ka expression, including the value of Ka. I didn't report that here. So I'm going to type that in real quick. 1.8 times 10 to the negative fourth. Make sure to use the text editor to make subscripts and superscripts as needed. And then determine the pH of a solution with a concentration of 1.55. Looks like I have everything pulled together for that question. Number 4, we're going to calculate the pH of a 0.57 molar solution of aluminum chloride. That's going to dissolve completely to give hydrated aluminum ion in this solution. So because my salt, here's the aluminum chloride salt, it says it dissolves completely into this substance here. So that means what I'm given is this concentration as well. So we're going to start our ice table. So initially I have this amount and I have none of this stuff. We're going to change that by an amount X, and then we have our K expression. So the Ka is going to be equal to 1.4 times 10 to the negative 5, which is going to be equal to my products, which is going to end up X squared at equilibrium, divided by 0.57 minus X. Now we're pretty close here to being able to simplify this. I'm going to go ahead and simplify it. So that means my 1.4 times 10 to the negative 5 is going to be equal to X squared over 0.57. I'm going to multiply both sides by 0.57 and I end up with X squared is equal to 7.98 times 10 to the negative 6. I'm going to take the square root of that value and I get X is equal to 2.82 times 10 to the negative 3rd. I do have more digits here, I'm just holding on to them, and that is a molarity, and that is the concentration of the hydronium ion at equilibrium. I was asked for the pH. So in order to take the pH, I need the negative log of that value, that 2.82 times 10 to the negative 3. And I get a pH that is 2.5. I actually get a 489, etc., because I think I was told hundredths place. Report to the hundredths place. So I'm looking to report here. I look next door. I'm going to report that up. So the pH is going to be 2.55 in this case. Now also I want to point out you should be able to convert between Ka and Kb. You should be able to work a percent ionization example, percent ionization problem like the nitrous acid example that's found on this page, and that is linked for you. You should also be able to tell if a salt solution will be acidic, basic, or neutral, and calculate Ka or Kb if you're given equilibrium concentrations. Specifically, look at numbers 6 and 7 that begin from the equilibrium concentrations given, blah, 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 that's on this page. Again, linked for you. I also want you to specifically work the aniline example that's found on this page. Again, linked for you. Now, if I link these things for you, it's highly likely that I have based your quiz problems on these problems. So be able to work those problems. You will have this the Ka constants available to you just like this on the quiz. So that shouldn't be a surprise, and then a periodic table as well.